Okay, today we're doing more unit circle fun. So we're going to try and teach you about sine and cosine and why you had to learn them back in 7th and 8th grade. Okay, so what we have here is a unit circle and we superimposed it on top of a Cartesian plane. So we've got this circle right here, and this circle happens to be 1, 2, 3, 4, 5. This circle has a radius of 5. And if you notice here, there's this lovely red point right here. Well, if I were to start labeling this circle, this side is 4, this side is 3, and our radius is 5. So it's a 3, 4, 5 triangle. Now, what we have here is the beginning of understanding sine and cosine. If you remember back from 8th grade, sine of an angle is the opposite side over the hypotenuse, and cosine of an angle is the adjacent side over the hypotenuse. So if we look here, opposite is 3, hypotenuse is 5. So whatever this angle theta is, its sine is 3 over 5. And its cosine is 4 over 5. And if we look here, we see 4 over 5 is in the x place, and we see 3 over 5 is in the y place. That's because the Greeks found out that when you're working with angles, the cosine of the angle is really the x value, and the y value is really the sine. Get it? Because when I draw a triangle, the x, which is moving horizontally, is the adjacent side to the angle, and the y value, which is moving up and down, is the sine value to the angle. So if I had to take this and measure this out, this point is really the point where I go over 4/5 and up 3/5. Get it? Because this is 1, 2, 3, 4, 5. So if that was my unit of 1, because remember it's a unit circle, which means it has a length of 1. So 1 unit here equals 5 spaces. So this I went over 4/5 of the way, and then I went up 3/5 of the way. So that's what you're going to be playing with today. You're going to be playing with different circles and seeing if you can figure out the sine and cosine of them. Okay, well here's another circle. Okay, and I'm telling you right now that that point right there is the point 5/13 comma -12/13. All right, let's see if we understand that. Okay, so the Greeks said that the x value of a point is the cosine of the angle, and the y value of the point is the sine of the angle. So there's my angle right there. Let's start working this out. Well, my unit is how far my radius is. And my radius here is 13. Right, because I just counted. I went over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So my radius is 13. So this is saying that this unit circle is a radius of 13. Okay, so then this is 5. I went over 5. And then notice I went down. Well, how far did I go down? I went down 12. And then this is the radius, which is 13. Now we got the radius from counting here, but you know we could have gotten the radius by doing Pythagorean's theorem. A squared plus b squared would get me c squared. Now here's our angle theta right here. So what is the cosine of theta? Well, the cosine is the adjacent side over the hypotenuse. And my adjacent side is 5, and my hypotenuse is 13. Okay, what's the sine of this angle? Well, the sine is the opposite side over the hypotenuse. The opposite is negative 12, and this hypotenuse is 13. Hey, wait, hey, look at that. Bingo. Bango. I don't even have to do any work. I'm kind of seeing that all I have to do is look at the value of the point, and I can figure out the cosine and the sine of the angle. Awesome. Okay. Now we've got a little different here. They tell me that I want to go over negative 3 radical 29 halves, comma 7 radical 29 halves. Oh my God, what kind of triangle is this? Awkward. Okay, well, let me just kind of randomly draw this. All right, so I see that my x value is negative. Now, I have no idea how far that is. I just know I go over a negative amount. And then my y value is a positive amount. So I go up. All right, can I make a triangle out of that? Because that's what trigonometry is, a triangle. Yes, I can. So there's my wonderful triangle. I know this is the angle. And if I would start to measure my sides, get it? Hopefully you know by now this is your hypotenuse. So this was 2. And we knew that this represented the cosine of my angle, which once again is the adjacent side over the hypotenuse. So if the hypotenuse is 2, the length of my adjacent side is negative 3 radical 29. So this side right here was negative 3 radical 29. And this second point represents the sine of that angle. So the sine of this angle was 7 radical 29 over 2. So that meant the opposite side was 7 radical 29 and the hypotenuse was 2. All right, so let's look at something a little different now. We're getting the idea that this is an angle, that it opens up and makes some kind of angle. So we're getting that idea. So 0 degrees. If I opened up this angle 0 degrees, which means it doesn't move. Now we know the angle. What is the sine of 0 degrees? Well, 0 degrees sine. Let me think here. I don't have a triangle drawn, so I can't do opposite over hypotenuse because there's no triangle there. But let's see what the Greeks did. The Greeks looked at it in terms of a point. Okay, so this is right here, and that is the point over 1 up 0. Oh, and that's right, and the Greeks told me that the first x value represented the cosine of the angle, and the second value represented the sine of the angle. Hey, hot diggity dog, I got it. So when I'm doing 0 right here, the sine of angle 0 is 0 because the sine is the y value, and the cosine of 0 is 1. You can check that on your calculator. What you want to do is press the word mode on your calculator. I want to make sure that when I look up here that degree is highlighted. So if it's not, move your cursor over, press degree, and then press enter. Okay, so if I do this now, the sine of 0, hey, look at that, it's 0. And the cosine of 0 is 1, just like we figured out. Okay, let's move this here. All right, so that is an angle that has opened up 90 degrees. And we can see 90 degrees right up there at the top. So this is the point over 0, up 1. So can you figure out what the cosine of 90 is and the sine of 90 is? Well, the cosine of 90 degrees is the x value, 0. And the sine of 90 degrees is the y value, 1. Because there is no triangle there. It's a quadrangle. It's right on an axis. So we can check it here, right? We can go sine of 90. Just what we got right there. Cosine of 90. Just what we got right there. Okay, so it's pretty good. Hopefully now we can fly through the rest of them. We can see next up is 180. So we got to figure out what the sine and the cosine of 180 is. All right, so I'm going to come over here and I'm going to open up my angle 180 degrees. So if that was 0, it's 90, boom, 180. Okay, so what's that point right there? Remember, it's a unit circle. So we went over -1 and up 0. Oh, I get it. My cosine is my x value. So the cosine of 180 is -1. And the sine of 180 is 0. And so you've by now figured out what this one's going to be. Let's say I take my angle and I open it up 270 degrees. That's pointing at the point 0, -1. So that's right. The cosine is the x value. So the cosine of 270 is 0. The sine is the y value. So the sine of 270 is -1. And this says the sine of 300. So I'm going to take my protractor and I'm going to open it up 300 degrees. And there, whoops, there is my angle. Okay, so what is the sine of 300? Now obviously you can take your calculator out and you can figure that out, but just let me show you what the Greeks figured out. What this would do is they would draw a triangle right here, and they would realize that this, let's expand that so it actually hits the circle. So let's get our triangle. We'd go up to there, over, and then down. Alright, so now we've got a triangle. So let's get rid of our angle. Don't need that anymore. And this is what they realized. This triangle is in a unit circle, and the unit circle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. But remember, it's 1 unit. So in this case, each space is 1/10 of a unit. And here is theta right here. So this was 1, 2, 3, 4, 5 roughly. So this is 0.5. And this is 1, 2, 3, 4, 5, 6, 7, 8. And it didn't quite get to 9. So let's call it let's call it 0.8 roughly. And then this is 1. This is 1 unit, right? We counted it over and we said 10. So each space was 1/10, so if there's 10 spaces, 1 unit. So now if I were to look at this, I would say that the sine of 300 is the opposite side, which is 0.8 over the hypotenuse, which is 1. So now if I take out my calculator and I turn it on and I take the sine of 300, look what my answer is. Negative 0.8660, not bad. And you can see now why it's negative, because I went down. All right, let's do another one. Now you have a calculator to do all this, so don't fret. You're not going to have to draw little pictures. But the point of the matter was, I want you to see that these were not just some arbitrary numbers your calculator was making up. These really work. All right, so let's take, I'm sure you can all hear my dog lapping up her water in the background. Let's reset this, and let's go 155 degrees. All right. And now she's crunching on her food. Let's take 155, let's put it over here, and let's make a triangle out of this 155. We'll drop, touches the unit circle right there, so we'll drop down. This is how far we want to cross. And there we go. There's my unit circle. All right, so let's just count up. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that looks like to be about 0.9, and it's in the negative direction. How far did I go up? 1, 2, 3, 4. A little more than 4. It doesn't look like it's 4 points. So I'm going to say I went up about 0.4. Or let's just say 0.45, because it looks like it's about halfway between 0.4 and 0.5. Let's see how good we were. The cosine of 155 is negative 0.9063. All right, let's see why we understand that. Okay, here's my triangle. This is theta. The unit is 1, and cosine is the adjacent side over the hypotenuse. Not bad.